Hi learners, welcome to my YouTube channel. So today we are going to do the part 2 of basic geometric terms. So first thing, let us see the midpoint formula. So this is x and this is the y axis. So we can take points over here, x1 and y1. So the mid of this one is going to be, this is the point of intersection. So that is going to be a x1, y1. And then we'll take here x2 and this will be y2. So the joining point is B, that will be x2, y2. So when we take this is y1 and this is y2, when we take the midpoint of that, that is going to be y1 plus y2 divided by 2. So this is the midpoint of it. And when we take this x1 and x2, the midpoint of this means always we divide it by 2. So we'll take this x1 plus x2 divided by 2. So this is that point. So the formula this will be, the midpoint formula is going to be what? This x1 plus x2 divided by 2, and this is y1 plus y2 divided by 2. So you can just see this is written in words. So if A, x1, y1 and B are the points in a coordinate plane, then the midpoint of the AB has coordinates. This is the midpoint formula. So now let us see for the distance formula. So here this is a triangle here. This will be A, B. So now if A is x1, y1, B is x2, y2, and this C, let us take this as x2, y1. So when we take this one, so what we can see here, this is x2, y2, and this will x1, y1. So here that will be when we subtract this one, what will happen here? X2 minus x1, and this y1 gets cancelled out here. Now again here what we can see, if we take this 2 and this one, so what remains is x2 and minus x2 gets cancelled, and what remains is y2 minus y1. So what if A, x1, y1 and B, x2, y2 are points in a coordinate plane, then the distance between AB is what? That is AB, this distance is root of x2 minus x1 whole bracket square plus y2 minus y1. This you will take the square of this plus this, because you know the Pythagoras theorem, that will be, this is the hypotenuse one. This is suppose the angle, this is going to be the opposite one, and this is the adjacent side. So we have this one adjacent square plus, this means this is also called as the base square, that is the base square plus this is perpendicular, or we can call it as the height, that is the perpendicular side is hypotenuse square. So this is the hypotenuse. So the base square, that is root of, so this AB square, this the hypotenuse square is AC square, because this is the base, and BC square, this is the height. So what we have, AB will be, when we square both sides, what will you get? This will get here as AC square plus BC square. So the AB is, this is what? Square of AC plus this is the square of BC. Hope you got this one. Now here the Pythagoras theorem, just a simple Pythagoras theorem. Now this is capital X, Y, Z. So this is capital, so we can put this as Y. This is Z, means we can put this all as Z, and this is X, means opposite of this is X. So this is the base, this is the perpendicular side, and this is the hypotenuse one. So base square plus perpendicular side is equal to hypotenuse square. So we can just put this one, because this is the base, that is X square, this is Z square, and this is the Y square. Now the segment bisector. So this is the segment. You know the segment means it is a fixed point. We have seen in the previous part. You can just have a look at it. And then we are going to bisect this segment. This AB is the segment, and we are going to bisect this segment. So now see here, this is the bisector. So here, what will happen here? Whatever the sides here, this will be unequal. So A segment bisector is a segment, ray, line or plane that intersects at its midpoint, and CD is the bisector of this CD. This is what? This will be extended here. This is the bisector of AB. When we write AB and put a bar over that, that means it says the segment. That is a fixed measurement. So now you can see from here to here, this will be the midpoint of it, and from here to here, this point is going to be the midpoint of it. Now the angle bisector. So now if this is a angle ABC. So this is the bisector, means these both are the equal angles. Whatever the angles are, these both will be equal. This is the bisector. BD is the bisector. So angle bisector is a ray. This and this is a ray that divides an angle into two adjacent angles. Means these are the adjacent ones which are at the side. So we can say ray BD. This is the ray BD bisects angle. This is the angle which is bisects into two congruent angles. What do you make congruent means equal. Whatever the angle you have, this one, the same angle will be here. So which one will be that? That angle is going to be ABD and angle CBD. So then the median of a triangle. So this is the median drawn. This is a triangle and this is the median drawn. So what again you can see, these both sides are equal. So in triangle ABC, D is the midpoint of this BC. So we can say AD is the median of a triangle. And when you see from here to here also, we can also take this midpoint also. Again, this will be the midpoint of that one. Or we can say this BD is equal to this DC. Both is the same. Exterior angle property. The sum of interior and the corresponding exterior angles are supplementary to each other. So exterior angle, what it is? That is 180 minus the interior angle. So this one, suppose this is there. So this is the exterior angle. It is what you have to do, from 180, you have to subtract the interior angle. Interior angles of a quadrilateral. So this is a quadrilateral, and these whatever the angles are, they are the interior. So what we can do, say here that the sum of measures of interior angles of a quadrilateral is 360. Means 1 plus 2 plus 3 plus 4. That should be 360. So measure angle 1 plus measure angle 2 plus measure angle 3 plus measure angle 4, that is 360. Now this is a parallelogram. So now PQRS. So when we say this line, these both sides are parallel and these both are parallel to each other. So parallelogram is a quadrilateral with both pairs of opposite sides parallel. So what we can say, PQ is parallel to SR and PS is this one parallel to QR. So if a quadrilateral is a parallelogram, that is opposite sides also are congruent. So this side will be congruent to this side and this side will be congruent to this side. So what we can say, PS is congruent to QR and PQ is congruent to SR. And then again there is one point, if a quadrilateral is parallelogram, that is opposite angles are congruent. So this angle P will be equal to this one and this S will be equal to Q. So we can say angle P is congruent to angle R and angle Q is congruent to angle S. If a quadrilateral is a parallelogram, that is, then its consecutive angles are supplementary. You know, the supplementary means it should be 180. So now consecutive angles means what you can see here. Now here this is S and this is P. So these both are the consecutive one. This should be 180. Or if we take this P and we take this Q, that will be 180. If we take this Q and if we take this R, that should be 180. If we take this R and if we take this S, this should be 180. When you add this both, it should be 180. So this is what is written over here. If a quadrilateral is a parallelogram, that is diagonals bisect each other. So these are the diagonals and they bisect each other. This is called the right angle. They bisect each other and this will be 90 degree. So what we can say here is M. So we can say PM is congruent to RM. And here when we can see this one, SM is congruent to MQ. Now the slope of parallel lines, I can say. This one, that slope is what? Rise over run. This is the rise and this is the run. So here what we can do, the formula for that is y2 minus y1 divided by x2 minus x1. Whenever the slope of parallel lines you have to find out. So M stands for the slope, that is y2 minus y1 divided by x2 minus x1. And whenever you have to find the slope of this perpendicular line, so with that product of slopes. So there will be two here. So M1 stands for the first one, this M2 will be for the second. So that should be minus 1. So M1, M2 is minus 1. So the equation of the line in slope-intercept form. So for this one, whenever there is a slope-intercept form, it should be y is equal to mx plus b. So here m is slope and b is the y-intercept. So y is mx plus b. Then for the point slope form, so y minus y1 is m into x minus x1. And here you have to see the points to find x-intercept. whenever there are problems based on it to find the x-intercept, there what you have to do, you have to take y as 0, and then you have to solve the equation for x. So the point will be what? Because that is the x-intercept means y is 0. So you know this is x and this is y. So here you should put 0, and here you will get something that will be the x. So we will write it x and 0. And to find out y-intercept, what we do, whenever you have to find out for y-intercept, you have to put x as 0. So this is x and this is y. So here you will put 0, and whatever the point you get, that will be y. That will be 0 and y. So these 2 points we have to remember. So now whenever there is angle, side angle, this is angle, this is side, and this is angle. So if angle A is congruent to angle P, so what we can say, this side BC is congruent to side QR, and this one we can say angle C is equal to angle R. So we can say triangle, this one BAC is congruent to PQR, because these both are congruent. So this should come in the middle. So PQPR. So angle side, this one side means that is also called as side SAS. So see here, can you see this is angle? This is SAS means this is side angle, and this is side. So can you see here? The same over here, side angle side. So what we can say, this AB is congruent to this one side PQ, and AC is congruent to side PR, and angle A is congruent to angle P. So this is what is written. So we can say triangle ABC is congruent to triangle QPR. Then side, side, side. So this is equal to this is equal to this one, and this will be equal to this side. So what we can say, when we say this AB is congruent to PQ, then BC is congruent to QR, and then AC is congruent to PR. So we can say triangle ABC is congruent to triangle PQR. Angle, angle, side. So here this is angle, and this is side. Angle, angle, and side. So what we can say, angle A is congruent to angle D, angle C is congruent to angle F, and this what we can do here, BC, side BC is congruent to side EF. This is what is written over here. And so we can say triangle ABC is congruent to triangle DEF. Now we have to see this triangle proportionality theorem. So in this one, what we can do here. So now this, whenever we write a line and draw, these are the parallel lines. So if if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides. These two sides, it will divide it proportionally. That means what we can say, that is, if MN is parallel to BC, then what we can do here, we can say MN, so that is here, AM divided by this MB is equal to AN divided by this NC. So this is what is there. These are the parallel sides. So this is the triangle proportionality theorem. Then the geometric mean theorem. So here this is a right triangle, and this is also the height, or we also call it as the altitude. So in a right angle, the altitude from the right angle to the hypotenuse. So what is that? Divides the hypotenuse into two segments. So now see here, this is 90 means this is going to be the hypotenuse. So it divides the hypotenuse into two segments. So the length of the altitude is the geometric mean of the lengths of the two segments. So what we can say here, that BD, this BD divided by this AD is what? Again, this AD divided by this CD. So this is that what you have to remember. Now the spatial right triangles. So from these spatial right triangles means right triangles whose angle measures are, which are the spatial one, 45, 45, 90 or 30, 60, 90 are called spatial right triangles. So here 45, 45, 90 means, now see here, this is 90 means these both here, they are 45. So now in this one, in a 45, 45 triangle, the hypotenuse is root 2 times as long as each one. So hypotenuse is root 2 of length. So suppose now this is x, So now you see how to do this one. X square means you know the base square plus the perpendicular side is equal to base square plus the perpendicular side is equal to the hypotenuse square. So x square plus x square will be what? We know this is x and this is x because these two are this one. So here this is the hypotenuse square. So 2x square is the hypotenuse square. So x square is, if it goes here, so that is going to be root of 2 into this. This is the leg of it, means root 2 into leg, we can say, means 2 into this x. So now 30, 60, 90 degree triangle theorem. So now this is 90, this is 30 and this is 60. In a 30, 60, 90 degree, the hypotenuse is, this is the hypotenuse. It is twice as long as the shorter leg, and longer leg is root 3 times. So this is the shorter leg and this is the longer leg. So it is twice as long as the shorter leg, and so shorter legs is x, so this will be 2x, and root 3 times as long as the shorter leg. This longer leg is, this longer is root 3 times, means root 3x. So hypotenuse is what? 2 shorter leg, and the longer leg is root 3 shorter leg. So this you have to remember. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of the other parts. Thank you.